Good afternoon, folks. So we're going to start the third game today. It's one that sort of originally when I was creating the class, I sort of had an assignment for, but stuff sort of shifted around, and I wanted to add a few things in about post processing, and a little bit later on after we mess around with this game a bit, we'll do a little bit of tile map stuff. So a few other sort of topics snuck in, and things got moved around a bit. So we probably won't do an assignment related directly to this one, but this is a much sort of larger game in terms of the number of scripts we're going to have and how those scripts interact compared to the previous two. Nick, yeah. So I created a repo for the starter sort of version of this. It has a lot of stuff already in there, so I didn't want to go through the process of creating like a player character and setting up the Cinemachine and stuff in Lecture. So I have that set up in that sort of starter repo that is on Blackboard along with the lecture slides for today. So there's a link to that repo, so you can download that and sort of start opening it up as I sort of give the sort of intro of it. So we're going to use some design patterns. There's going to be a little bit of AI stuff that we do sort of in between. So you can sort of think of the next 3-ish weeks devoted to the game. But in the middle of those, we're going to talk about some movement AI, which is the sort of type of AI that we're going to use here. The AI stuff that we're going to talk about, I have the book here somewhere. It does come from one of the books that I mentioned at the beginning of the semester. That's in the syllabus. This Artificial Intelligence for Games. This is basically the book that, if you want, I know all the text is backwards here. If you want to look at sort of AI and sort of how you mess around with it in games, and lots of examples and diagrams, pictures, that's the book to go for. I know that I'm pretty sure that the AI for Gaming class that Professor Folajimi teaches also uses that book as well. So it is an important book for sort of general AI in video games. And that's everything from movement AI, which is what we'll be talking about for this game, all the way to more strategic AI for games, for sort of strategy games that you've probably played before. So it's a great book. We're doing just a little bit. This isn't sort of an AI class. There's obviously whole semesters you could do on that. So we're just going to do some movement AI stuff. So I'll show you what the game's sort of going to look like once we jump into Unity here in a second. So we'll do a little bit of that in between. So that's a little bit more math type stuff. We're going to be dealing with vectors and things and figuring out what direction the enemies should move and when they should sort of stop so they don't follow you and bump into you if you don't want them to. For example, we'll create a ranged enemy that stands a certain distance from you, or at least approaches you to a certain distance and starts shooting. So we need to make sure that sort of enemy AI knows how to do that. So it knows where you are, how far away it should stand, and that sort of thing. Along with that, the systems that we're going to create to facilitate that movement AI, I am planning on making that relatively flexible. So if you create a simple movement AI and then later on you come back and you say, maybe I should use a different type of movement AI for melee enemies compared to ranged enemies, like a completely different type of movement AI. It'll be as easy as removing the current AI component and adding a new AI component to the enemy game object. So that's sort of how I plan to make this extensible. Along with that will be a couple of finite state machines, one like we've been using for game state, and a second one for a boss type enemy to determine the boss's movement. So what the boss does, depending on how much health it has, essentially. So when the boss is sort of greater than 50% health, it'll move between some patrol points, and when the boss is less than 50% health, it will change state to chase the player. So similar finite state machines, they'll have the same style of code, but it'll be controlling what the boss is doing sort of movement wise. There'll also be another design pattern, the factory pattern, which I think I talked briefly about. Maybe I didn't, but in any case, we'll use a factory pattern for spawning the enemies, which is very useful. It means that our spawner doesn't have to know the specific enemies that have been spawned. So if you spawn a wave of enemies, it's going to be random whether you get ranged enemies or melee enemies. But the spawner's not even going to know. It's not even going to know which is which, because it shouldn't need to care which is which. The enemies will control themselves. The spawner just needs to create a bunch of them. So we'll use a factory pattern to help us deal with that. So the purpose of this one, it's going to be larger, but it's going to be more extensible, and it's going to show you some of those design patterns and some of those tools that you can use to make a game that will be or could be expanded on in the future. And hopefully you could apply that to games that you might work on, no matter what engine you're using. A lot of this stuff, finite state machines and factory patterns and having sort of an extensible AI system, doesn't matter what engine you end up using, you can adapt it to basically any engine you want. So that's sort of the plan as we go into this one. So today is mainly focused on the player. We're going to get the player moving. You will recognize the player sprite, but this time that particular player sprite does have a weapon. So it has this little wand thing that after today will track your mouse around the screen. You'll be able to move in 2D, so you'll be able to use WASD to move around, and the Cinemachine camera is already set up with a couple of extra things that I'll talk about briefly. So yeah, so basically I'm going to show in Unity here. I think there was one thing I missed when I was making the starter version of this, so I'm going to point that out too. So this is our game world. The camera view is, let me turn on my pen attention thing here. Get that going. There we go. So the camera view is the white square here. So in game mode, we're going to see this. You'll certainly recognize the snowman, but we have this little wand thing. I do have all the animations and stuff in here. So I think right now, if you play, I think there'll be there might be like a warning or something. Yeah. Which I'm not sure if that's no, okay. So everything's playing. There's a couple warnings. I'll point out where that problem is. But you'll see we have the animation for the snowman. Right now the keys they don't do anything. We haven't obviously coded anything yet. And this little sort of wand thing has a little sort of fiery end that sort of looks like it's sort of flickering as well. It's just it's just some scale movement on it. So some simple sort of quick animations. If you import the project or load up the project and you're not getting this scene, it is in the scenes folder here, so you should be able to load up that particular scene. This is in the universal render pipeline, so we have the capabilities to make custom shaders with shader graph and all that good stuff. On the manager game object, there were a couple scripts that I apparently didn't get rid of, so you could basically just get rid of these. So on the manager game object, we will have a couple of managers in there, but you could just go ahead and get rid of those, and that'll get rid of the warnings down here. They're not sort of breaking anything, but if you want to get rid of the warnings that are popping up, then you can just get rid of the game or the scripts that were on the manager, because those scripts are no longer there because we are going to write them. There are walls here as well. So these are the walls. When we eventually move around, we're going to hit the walls. There is the background, and the background includes two things. It has a plane with just a texture on it. So I went into Affinity Photo and I sort of created this texture. That way we can tell we're moving around. So as we move our snowman, this time with the weapon, it'll move sort of around this, and the camera will follow. There's also a collider, and this has to be a polygon collider. There's reasons for that I'll mention in a second. And I call it camera collider. I want to restrict the camera to not go outside of my texture. I don't want to see this background back here. Even if I made the background like black or something, I still don't want to see it. I just want the camera to move and then stop. So if you think of a game, any sort of 2D game that you played before, but a game like Isaac or something where you have, like, say, a large room. So one of the larger rooms, if you're playing The Binding of Isaac, it doesn't have the camera like go outside of the walls of the room. So that's the idea here. I don't want the camera to ever view outside of the bounds of this plane. So I have this collider, and the bounds are the green here, and it's set up to be just slightly smaller than my plane with that texture on it. So the camera's never going to sort of peek over the edge this at any point. And how I do that is relatively easy. In my Cinemachine virtual camera, I added an extension. So there's a whole bunch of extensions to add in here. I added the Cinemachine confiner. And all you do is you pick the dimension. So in this case, it's just going to combine in 2D. And I add in that camera collider with the polygon collider 2D. And that's it. Now my camera is confined within, you can see the collider here is yellow because it's showing me what collider I'm using for the confiner. So there's a whole bunch of little extensions like that that can help you do things in a very easy way. I didn't have to do any code to stop the camera from moving past a certain position. So this is something that, of course, you can look into, find tutorials about stuff. But if you want to take a closer look, because I've already set it up, you can mess around with what this is and the collider, and you can mess around with all of this. But I wanted to have this stuff set up so we didn't spend tons of time sort of messing around with it and trying to get the perfect thing. I don't have any aim set up here with the camera. It's always going to be looking straight down, so I don't need to like rotate the camera to do any aim. And for the body, all I do is lock to target with world up. So it's just going to be locked in to the player itself. The target up here is the player. It's going to be locked into the player, moving around, but the bounds of the camera will not move past this box. So that's the sort of the camera setup here. And you could do this with, if you had multiple levels or something that you wanted to do that your player was progressing through, you could easily set up every single level to have some sort of confiner and set it up to lock to the player. So it'd be sort of an easy thing to do if you wanted sort of one level per scene or something. For the player itself, we have a couple components underneath. We have the graphic that just includes the head and the body. So that's the thing that's sort of doing the idle animation. And then I have this weapon. I left one of the components on here that we're going to talk about today. It has a particle system. And you can tell that from the little gizmo here, from the little sort of particle icon gizmo thing. It has two pieces. It has the handle. And underneath the handle, I should have used a graphic and had the handle in the body like I did with the player, but I didn't do that. So I have the handle and the fire. The fire is the thing that's animated here. And then I have a particle system. And it might seem kind of weird. If I play the particle system, you see it shoots out, but it only shoots one. So we're going to talk about that a little bit later. I'm actually using the particle as the projectile. For our enemies, we'll instantiate another game object and all that stuff. But I wanted to show you another way to use the particle systems. The particle systems are going to hit the enemies and cause the enemies to die. That's how we're going to use this particle system. So it's not just for making some cool effects in your game. You can use it as an actual sort of game component that interacts with things in your scene. So we're going to look at that a little bit later today, because we're essentially going to get this player moving. If the mouse is in our screen, we're going to have the wand thing point towards where the mouse is. And then when we click, we're going to play the particle system. So one particle shoots out of the particle system. So that is going to be today. So does anyone have any questions just on that little sort of intro piece?
So for the particle system, how is that going to hit the player? Does it have a collider, or is...
Yeah, so you can take a closer look at the particle system because I did leave it in there. The only stuff that's checked here, and these are things you can of course mess around with. This is very simple, but it's just emission shape, and then down here, about a little bit lower than midway, is collision. So we're going to talk about this. We're going to talk about what exactly this is doing and how this is all set up. But you can have collision with particles. And then in code, you can actually set it up so when a particle collides with something, you can basically call a function.
Okay, thank you.
Yep. Yeah, so particles, if you have, let's say you had some sort of rapid firing weapon or something, so like a machine gun or something, and you wanted to have you wanted to be able to see the bullets or something, you could just instantiate objects all the time. So instantiate your bullet object and have it move and all that stuff. Or if it works, you could just use a particle system to do it. And a lot of that stuff that you would normally write for some of your scripts for like some sort of bullet projectile, you let the particle system handle. You let the particle system handle the movement, and you let it handle things like a color over lifetime. You can add forces so that when it hits something, it could push something, for example. So the particle system can handle a lot of that for you, which could make your life a little easier if the particle system will work for what you want it to do. So that's some of the stuff that we'll see at the end of today. So I'm not quite sure exactly how long today's going to go because there's not sort of a ton of code to write, but some of it will take a little bit of explanation. So the place I want to start is the finite state machine. Essentially, we can just copy the one we had for Flappy Droid and then just delete some of the extra stuff. For now, I think I'm only going to put the play and game over in. We might, I don't remember if I have all the slides for this or not, if I left them in. I did some reorganizing of this after the semester started. So I don't remember if we're going to do a pause and a menu state, but of course, if you want to add one in, it's as easy as adding a state and then adding a class. And we're going to want a reference to the game manager. So very similar to the Flappy Droid one. The game manager will do a few things there'll be a few calls to the game manager, and we're going to work out some of those today. So I'm basically just going to I have my one from Flappy Droid here, the one that we coded in class. I have it just coded up here, just open a notepad, and I'm going to copy and paste that one out to a state class that we'll make here in a second. Again, I'm just going to make two classes for the moment. I'm just going to have play and game over. That's sort of all we'll need, at least for a little while, and we'll see if later on we'll make a pause and a menu. So same sort of thing we've done before. So if you have the other project available, just go grab the state class from that, and then we'll just clean it up a little bit so that it's basically a brand new state class, and we'll start adding stuff into it here in a second. So what I want to do is over here in scripts, there shouldn't be anything in there. It should just be an empty folder. I'm going to create a new script, and this will be my state script. And I'm going to open that up. So here's this. It's not a mono behavior, and in fact, I'm just going to copy and paste. So I'm going to delete everything in here, and I'm going to grab my other one and copy and paste it in. I think this have, no, this doesn't. I wasn't sure if it had all my comment stuff at the beginning. So I'm just going to have play and game over, mainly because that's the one that was in my Flappy Droid to begin with. I'll still have all this stuff here. I do need a reference to game manager. We haven't created that class yet. We'll do that in a second. So I'm going to make this protected so that my subclasses can access it. And this will be game manager. And I'll just call it little game. So they'll have access to it there. Everything else in the main class is the same as it typically is. And then in play, I'm going to get rid of all the sort of other stuff, all the Flappy Droid specific thing. So in enter here, I don't need the reset. I don't want any of the comment stuff here. So the zombie code here or the spawn pipe, I don't need that. We will add something in here in a moment. And then for the game over one, I'm going to get rid of the stuff in update. So just cleaning it out, getting it sort of all back to sort of a mostly pristine state with, or mostly pristine sort of set of classes with just the play class and the game over class. So we're going to add something to update in a second, and we're actually going to add a bit more later on. There's going to be some changes that we're going to make to today's stuff to make this a little bit better. We're actually going to add a fixed update function within our state classes. The reason for that is mostly because the physics system should be updated in fixed update, and the graphics and input should be done in update. So we haven't separated that out, and we're going to start by keeping it together, but later we will separate it out, and I'll show you how to update our finite state machine to have a fixed update type class or fixed update function and a sort of regular update function that we run in our update in our mono behaviors. So just again, just a clean state class, and we'll modify this. We'll add to it here in just a few minutes. So that's basically all this first slide is talking about. Okay, so let's create a game manager. We're going to need to add the singleton stuff to it so that we can use it just like we have been for the past stuff. And I don't know if I have my singleton stuff all open here. Let me see if I can grab that real just going to grab it too so I can just copy and paste it. So if you want to do that as well, just that beginning. Okay. Yep. So I have my singleton parts here. So I'm going to copy those in once I make the script. And then we're going to add a couple things to our script here. And I'll sort of describe why this is going to be important for us to use as I go through and do that. So I'll make a new script. And this will be our game manager. And it will be a mono behavior because we're still going to have start and update. But the very first stuff I'm going to put in is all of that singleton stuff here. So we've got our private static game manager instance that's null in a wake. So we're just doing the very simple, the very simple singleton. If instance is null, then instance is this, and then we have our function. So it's the same sort of stuff that we've been doing for the past few games as well. So that's our little singleton part. This means that our state class will easily be able to grab our game manager. So our state class will easily be able to grab this, and we'll be able to call any functions we need from the game manager, which is something that we will be doing. Okay, I think close these out. Okay. All right, so in our game manager, after our singleton stuff, we're going to create a play state. So we'll create a quick state object and have it be new state. And then, of course, in update, we're going to have that be process. So this is our normal game state update. I'm going to create another function as well. It's going to be called entity action. So this is where the movement and potentially the attack actions of our players and our enemies actually takes place. So we're actually not going to use update in our player or in our enemies. It's all going to happen from here. We're going to call entity action from the update method in the play class. So in our play state, that's where we call entity action because process happens every frame. So it is a little bit of misdirection here. It's not our player, all of our player code isn't going to be, we're not going to have an update in our player object, on our scripts that we attach to our player object. But that makes our game state easier to manage because if we want to pause the game state, we just don't call entity action in a pause state of our game. Rather than having to use Booleans and check those Booleans every single frame, we just change our state and then the characters and everything no longer update. So it does give us that sort of flexibility. It makes either making more game states or changing how the game states work easier than without having to handle all these Booleans and stuff that we might have to check in multiple scripts. So we're going to add these pieces to game manager, and we'll add in our play state, we'll add this game manager.entity action. So back here, let's create a quick variable for state. So this will be a state variable. Then I'm going to call state. And here we'll say state equals new play. I might need to recreate the we'll see if we have all of my autocomplete stuff. Should be a new play. So it should. We might need to. We'll check. It might just be. This might just be a. We just do a code thing where it just doesn't know where it's at. I might need to recreate the all the assembly stuff. So create a new play object, And then in update, that's where I do state.process. And again, it doesn't know anything about state at the moment, so we might have to remedy that. And then I want that entity action function. So this will just be public void entity action. Yeah. And we're going to put stuff in here later. So more stuff to come. In our state class, in the play state, in update, this is where I add game manager dot entity action. So when we do our process, the first thing we'll do is enter, then we'll do update. So this function, this entity action function, is still called every frame. And that's where we're going to put things like, more to come, like player.move. So that's the sort of stuff that will go in here. Or enemy.move, enemy.attack. So those are the sorts of things that are going to go into this entity action. Now, let me see. I don't know why state is being a little bit of a pain. So let's let that compile. And let me check the...
For me, I just had to save, and then I got rid of the red.
It should be all saved up here. So let me... I may have to regenerate the project files is something that I might have to do. It should still play fine. I think it's just Visual Studio Code just can't find it for whatever reason. And, okay, we'll wait a second, see if that loads up. If not, then we'll still click play once we add this stuff to it and make sure that it at least still runs, even if there are errors popping up. And yeah, so it looks like that was good. So it looks like I just needed to recreate the the project files. Okay, so hopefully, based on the stuff that we've done before, hopefully this sort of all makes sense. The singleton piece, we had a clean finite state machine, added in a few sort of normal things, creating a new play state, creating the process, or putting the process in update, and having this entity action function, which is called during the play state's update. So this is still called, and it'd be worth putting a comment here, called every update frame. Just so we know that, yes, this will be called every frame. Even if we're not an update, this is something that happens during every frame. All right, so let's attach this to our manager object up here in the hierarchy. So I'm going to take my game manager and put it up here in the game manager, or in the manager object. We're going to put the spawn manager on this same object as well, so we will have more than one there, but for now it's just game manager. If you want separate objects, that's perfectly reasonable as well. You can always have just an object called managers and then have a whole bunch as children or something for game manager and audio manager and whatever. For the player, it has all of its normal stuff. It has its rigid body, it has a sprite renderer, it has the box collider, and it has an animator because we have that little animation. So it's the same sort of stuff that we've worked with previously with all of our 2D things. We are going to add our script to this, though. We're going to add our player script. So I'm going to create that. Add player. And once that compiles, gets created, I'm going to drag that onto this player object here. So I should have the player script. There's nothing important in it at the moment, but that's something that we're about to add. So let me open it. So Joey, no, the state script is not a mono behavior. So state is just a regular C# class. So we can't actually attach it to anything, but we can use it like a regular class in our other classes. And we're going to do the same thing in a couple different ways, because we're going to have a class that deals that I think it's called, we'll have an interface called AI move, and we'll have a regular class called AI movement. And that will also be something sort of similar. We'll have a component that we sort of add to things that is the AI movement. So we're going to do some similar stuff later on as well. But no, the class, we can use it as a class in other classes, but it itself is not a mono behavior, so we won't be adding it to anything. Okay, so our player script will still use start, but it's not going to use update. We have our update already. It is that entity action. So we're going to have the game manager call some stuff related to the player. So we'll still have start. We're still going to add some stuff in there, but we do need a few variables. These are going to be standard variables that you normally think of when you sort of start thinking about games and the games that we've written so far. Things like the speed, things like a rigid body, a health, the movement that the player is going to have. So we want to think about which ones we want public, which ones we want accessible in the inspector in Unity, and which ones don't need to be. So for example, a public that we might want is the speed. So that'll be accessible in the inspector. We can change it when we need to. Something that could probably be private could be something like the rigid body. This would be a rigid body 2D that just name just lowercase rigid body. We're going to have a few more. I don't remember if I've showed this to you guys before. Let's say we want a private variable. And it doesn't matter what it is. Let's say it's max health. So we want a private variable that's max health. Let's say we want to try to follow the OOP principles that you've sort of been using the entire time you've been programming, the encapsulation and the abstraction. By making this speed public, anybody can access it that has access to player. So yes, it's nice that it's in the inspector, but maybe we don't want it to be easily accessible to all of our other classes that have a reference to player, which they could potentially get a reference to player through the game manager. What you can do is this. You can use the square brackets, and you can tell Unity, this is a Unity thing. We can tell Unity that we want to serialize the field. So it should pop up in your autocomplete, but it'll be like that serialized field. So what this does is this tells Unity, hey, no matter what the visibility is, I want this in the inspector. So this will now be in the inspector. So you can do this for any of your variables. You can have all of them be serialized field, and then it doesn't matter what the visibility is according to C#, it will always be in the inspector. So that's something you can do. I don't remember if I mentioned that before. It's a similar concept to throwing in the stuff up here, like the require component, type of, rigid body 2D, for instance. So it's a similar sort of thing here. It's sort of it's letting Unity know that, hey, we need something specific on our game object, or something specific related to the Unity UI. So you can use that serialized field wherever you want to. You can also serialize other stuff as well. You can serialize classes and stuff, which is actually pretty cool. You can do like scriptable objects and stuff. So we won't be talking about those, but they are quite useful as well. Let's say we want a private int for the current health. So I'm just going to call that health. So whatever the current health of this of the player actually is compared to the max health. And then we might want we should have a vector 2. We'll go with a vector 2. This is going to be our movement at any given point. So if we're holding up on the keyboard, this vector 2 will represent an up vector. So I'm going to call it an up vector multiplied by our speed. Right? No, I think it's just the up vector, the way that we're going to code it. So this is going to be, I'm going to call it like move amount or something. So that can be private. No one else needs to access that. In start, we should probably grab a reference to our rigid body. So our rigid body is going to be get component. So we're making that assumption that the rigid body 2D is part of our object, which it will be based on our required component here. So we want to grab that rigid body component so that we have it. And then I also want to set the health, so the current health that the player has, to the max health. So we're all sort of reset. As soon as the player becomes available, we grab the rigid body, we set the health to max health. we have a couple of functions that we're going to fill in. So I'm going to sort of outline them at the moment. So we're going to have a public void, and there's a couple related to movement. We're going to have get movement. So this is going to fill out, it's going to fill the move amount vector based on user input. So if we're holding down some keys, whether it's WASD, whether it's arrow keys, we need to make sure that this move amount vector is correct based on the keys that we're pressing, or in principle, if you have a gamepad or something, based on the analog stick and how you're holding it. Then we'll have one that is just called move, and this is where the actual rigid body gets changed. So the actual movement. This is going to get called from Game Manager. So in our entity action, we're going to call player, whatever our reference to player is, dot move. So this gets called from Game Manager in entity action, which means it gets called every frame. So that's sort of how all this stuff links up together, where we don't need an update in our player script, but this is still getting called every single frame because of the way we've set up the game manager and our state machine. We also need a function to take damage. I don't know if we're going to hook this up to much of anything. Because we're sort of short a lecture over the next 3 weeks because of Thanksgiving, so I don't know if we're going to have everything hooked up by the time we're supposed to finish this. But you can imagine that you might need a take damage script or function. And amount has to come into that, some value that you take damage, and you might do like a health. Helps to spell things right. And then, in here, you'd probably have something, if health is less than or equal to 0, then we die or something. So we can destroy the game object or play something, or for now, print something out. I mean, who knows? Whatever you want to do. So these are our basic functions for our player to get it to move. We're going to take the weapon, we're going to add a script to that's separate. So this really just needs to deal with the movement and managing the health of the player. So it's really not going to be a ton of stuff in here for us to mess around with. So on the slides, there should be that as well. So we basically sort of written sort of these pieces, got a few of those functions. Again, there's no update. A finite state machine is going to handle that along with the game manager. And we don't have to do a lot of sort of extra coding stuff because we're going to do a rigid body for the movement, and we're going to use the input class for detecting key input. So it's really only a couple more lines of code, and the player is going to be moving around. So here is our get movement function. So I'm going to write this first, and then we'll come back and talk about the stuff that I've put in here in the slide. So for our get movement, this is where we're setting the move amount. So we need, I'm going to create a vector 2. I'm going to call it move input. So this is the input that would be coming in from the input system. So there's going to be an X and a Y. I'm using a vector 2. So I have an X and a Y. We don't have a third dimension here, so we don't have to worry about Z at all. And it's going to be a new vector 2 with 2 inputs, the X and the Y. So the X is the horizontal axis, and the Y is the vertical axis. So we're going to use the input class to do this. So we're going to say input dot, and we did this before. We did the get axis raw, and then we put in the name of the axis. This is something you can change in your project settings. You can change the name of the axis and what it represents and what keys it represents. But if you're just sort of starting a project from scratch and you do horizontal, then that's going to give you the x-axis of whatever it is you're moving. So this will be like A and D, or the left and right arrow keys, or left and right on an analog stick. And then for the y, as you can probably imagine, we're going to do input dot get axis raw, and we're going to have the string here be vertical. So this gives us the raw values for our movement axis. For pressing on the keyboard, there is no in between like there would be on an analog stick. So it's just going to be 1, 0, or -1, depending on which direction you're moving, or no direction at all. After that, you have the direction, but it's not related to our speed at all. So this is where we say move amount. This is going to equal our move input dot normalized times our speed. I think we've used normalized before. If I don't remember if we used it for the first game or not. So in the slides, we're moving in 2D, right? So we have this 2D vector. Normalization is essentially, for a vector, is essentially giving that vector a length of 1. Because remember, a vector is a direction and a magnitude. So this is probably most important for analog stick type things, because it's not going to have too much of an impact if you didn't normalize it for a keyboard, because everything is just 1 or -1. But especially if you have an analog stick, if you don't normalize the vector, that vector might be greater than 1 in its length. The reason why we want a normalized vector to represent our direction is because now we can directly control, by a multiplication, the length of that vector. And that directly represents the speed, right? Velocity is a direction and a speed together. So if we know the direction, which has a speed of 1, we can multiply by any speed we want, and we get our appropriate velocity. It's the same reason why random number generators typically will go from 0 to 1. Because then you have the control to multiply that by a number. If I multiply my random number generator by 10, now I get random numbers between 0 and 10. So it gives you the power to multiply by things, and you know that you're just the starting place, move input dot normalized, the starting place is just 1. And so now you're directly controlling the length based on what you multiply by. Any vector can be normalized. If you're using a game engine that doesn't have like a normalized function or something that you can call to normalize, it's just dividing each element by the length. So you compute the length of the vector and take each element and divide it by the length. So this is a very typical thing to do. If you're working with vectors and you know that you need just the direction and you don't care about what the magnitude is, you just want the direction, then you should normalize it. So this is a very common thing to do. Take whatever a vector is, normalize it. You have at that point you have just the direction and a speed of 1. So in our get movement, this gives us the move amount, how much we're going to move in that frame based on what the user's pressing, what keys are pressing, left, right, up, down, multiplied by the speed, or whatever speed we set, since it's a serialized variable. Sort of talked about these. So this is something you can sort of come back to if you forget sort of the reason for normalization. All right, and then in move, so in our function in move, we're just going to do get movement. So every frame we will be getting the movement, and then we'll do RB, so our rigid body. I think I have it spelled out, rigid body in our code, move position. And that's all I'm going to use. I'm not even going to use any of the velocity stuff. We did the impulse stuff before for the Flappy Droid game. We're not even going to bother with that. This is just going to be move position wherever we were, plus the move amount times delta time. I have fixed delta time here. We actually don't need that nowadays. There's actually was a relatively recent update that made it so that it uses the appropriate delta time where you want to have it. And eventually we're going to move this rigid body calculation out of this move function. So for now, we're just going to do rigid body dot position plus move amount times time. So that move amount is a vector multiplied by something small, and we only move a little bit every single frame. So back here into move. This is when we call get movement. And then we do our rigid body dot move position. And we take our current position. So I can say rigid body dot position. You could also use a transform dot position in here as well. And we could say move amount times time dot, and we'll just use delta time here. So we're almost done. We've got our function that moves every frame that will move our object a little bit every single frame, grabs the movement from the keyboard, computes the normalized vector, multiplies by speed. So we're almost there. We're almost ready to go. Back in Game Manager, we need a reference to the player. So I'm going to make this public. This will be a public player. Public player. This. And in entity action, we're literally just going to do player.move. So public reference to player, because we're going to drag it in. It'll be available in the inspector. And entity action called every frame. So hopefully just with this little bit of code, you can sort of see where this is going, how we're going to mess around with our enemies in the same way as well. That we'll have here, we're going to have some, we're going to know a list of all the enemies, and we'll have something like for each, enemy E in enemies. So something kind of like this, and we'll go through and move each of the enemies and do whatever attack stuff we need to do and all of that. So that's what we'll do inside of entity action, because that's called in our state machine right here, every update. So I know that it can start to get a little sort of intermingled, but again, the state machine and the way we're using it means that it makes it easy to create more states, specifically something like a pause state or a menu state. It makes it easy to do that, because then we don't have to worry about things moving after we change away from play mode, for example. Okay, any questions so far? So we're gonna mess with the weapon next. After we'll add the player script and hook everything up here in the inspector and make sure our character actually moves. That would be a good thing to test. So I'm back here. I'm going to take the player script and I'm going to add it to our, actually, yes, I already have it in there. So let's change the speed to something reasonable. I don't know, 5. And maybe we'll have like a max health be 3 or something. In our game manager, I need to hook up the player here. So I'm going to take my player object and drag it into here. So I've hooked it up in the game manager. I have my player script with a certain speed. And so we can cross our fingers and hope that this will go. No, it is not. So let's see where we're at here. Game manager. Yes, I never set the game manager up here. So I just have the reference to the game manager. I need this to either be, let's do this rather than, so this is in our state class. I didn't set up the game manager specifically. We could probably do that in the constructor here. So the constructor for state, I can say game manager equals game manager dot instance. So I never did this piece, which is an easy one to forget. So I need to use the singleton part of this. So as soon as that first state class gets created, of course, we're going to grab the game manager, and now we have access to it where this should work. So that goes correctly here. And if I move around, it's moving a bit slow, so I should probably crank that speed up. But it is moving based on how I have my arrow keys. So let's get that speed a lot faster here. Yeah, it's doing a little bit of sort of jerking around, and so I think that probably has to do with our update stuff, our sort of fixed update stuff. So we will mess around with some of the fixed update stuff a little bit later. you can see that I can't go, if I try to keep going sort of one direction or another, get to one of the corners or the edges or something, the camera's not moving there, and the player's not moving there as well. Let me check. It's definitely moving really slow. I'm going to put fixed delta time in here. I don't think this will have a impact on this. Okay, it's a little better. Still a little bit jerky. The fixed delta time is something that you typically only want to use in a fixed update function, and we will use a fixed update function. This is just getting us started. We're going to mess around with the state machine a little bit more later as well. All right, Nick. So our state machine. The thing that I just added was the getting the reference to the game manager in the state constructor. Otherwise, the only sort of thing in here, other than the sort of normal boilerplate stuff, is the calling of entity action in the play state. Otherwise, everything else is essentially the sort of the base way that we had it before. All right, so I want to work on the weapon as well. I want to get this weapon working. It's not going to take too long, but I think it'll sort of show you some stuff that you can do with the mouse. And I know we haven't really messed with the mouse that much. It's mostly been keyboard type stuff. So it'll show you a few things that we can do with the mouse. So I'm going to create a new C# script, and I'm just going to call it weapon. Obviously, if we had more different types of weapons, you might want to have some scripts or an abstract class or something, and then subclass off of that. But I'm just going to call it weapon. We're only going to have sort of one weapon to deal with, and this will go onto the weapon, what I've called the weapon 1 game object. So let's just go ahead and drag that on here. So just our empty script on there, but it's going to be on this weapon itself because we're going to deal with the rotation. We want to change the rotation of, if I have my weapon selected here and I do the rotation, rotate in the Y direction, rotate in the Z direction. I want to do something like this. So I want to be able to rotate around like this. It kind of looks like it's attached to the Snowman's button. So I want to be able to rotate around like that in code based on where my mouse is located. So I'm going to open that script. And we don't need to use start, but I am going to need a reference to a particle system. That's going to be for our projectile. So let's go ahead and throw that in there. So this can be public. You might want to, change the particle system or something. Maybe you get a power up and now the particles, glow a different color or something. You might want to change the particle system in some way. So we should probably have access to that so we can swap things out if we need to, if we had some like pickup system or something. So this will be a particle system. And I'm just going to name this, I don't know, weapon projectile. Okay, so an update called every single frame. The game manager is not going to manage this. You could have the game manager manage it. You could. There's not really sort of a reason stopping you, but I'm not going to have the game manager manage this. So in other words, the state machine is not going to manage this. It's just the weapon's just on its own. It's always going to be pointed at the mouse, irregardless or regardless of whether the whatever state the game happens to be in, according to our state machine. So the first thing we need to know is the direction. What direction should this wand be pointing? This can be tough to figure out because there's a couple of different sort of world type things going on here, a couple different Unity world type things happening here. When I'm in game mode, my mouse is inside the camera view. And my camera is whatever resolution. So 16 by 9, whatever, I'm 1920 by 1080. Right? Well, I need to know what happens if I'm over here. Let's say I'm over here, some pixel, I'm over here at pixel, 1700 and whatever, 300 or something. What is that in Unity space? Because behind the scenes in Unity, there's all these grid locations here, and each of those represent like a unity unit. If I want to compute a direction, my player, or my wand in this case, it's located here in unity space. I don't know where it is on the screen, in the pixel space on the screen, but my mouse is in pixel space on the screen. So we have these multiple sort of units of where stuff is. We have a screen position where our mouse is, and we have a transform dot position in unity space where our wand is. So we have to do some conversions. Luckily, this is very easy to do. Unity has functions built in to do this, as you might imagine. So first, let's compute the direction. So I'm going to create a, I think we can get away with a vector 2. And I'm just going to call it dir for direction. Since the camera is responsible for rendering the image, or for what we're seeing, I should say that the renderer is responsible for rendering, but the camera is responsible for what we're actually seeing. The camera has some static functions that allow you to do a calculation, to do a conversion from one of these spaces to another, from this pixel space to unity sort of world space. You can always access the main camera by saying camera.main. And then we can have functions associated with that. Now, you need to be careful with this. Camera.main must have, you must have a main camera, and it must have this tag. It has to have this main camera tag. This is one that's built in, so it's not one that you have to add, but it has to have the main camera tag. If you have cameras in your scene and none of them have the main camera tag, then camera.main will not work properly. So that's one of these little sort of caveats. So we say camera.main dot screen to world point. So this will take a screen point, a position, and turn it into a world point, which is what we want because our transform on our weapon is in unity world space, but our mouse position is in screen space. So I need to put the screen space position in here. That's input dot mouse position. So this is where my mouse is located in unity world space. Then we need to do a subtraction. So this was way back when we first started talking about some of the vectors. We subtract two vectors, we get a vector that points between them. So I would say minus this dot transform dot position. So this is our weapon, the transform on our weapon. This is where the mouse is located, converted from screen space to world space. You could normalize this as well. I don't think we need to, because we're just going to compute an angle. But if you needed to normalize it, that's something you could do as well. Now this gives me the vector, but I need to rotate my weapon by a certain angle. That'd be the equivalent of me grabbing the Z handle and rotating it. So I don't just care about the direction, I care about the angle that I need to rotate my quaternion. This is getting back to the quaternion representing a rotation in 3D space. So I need the angle that I need to rotate. We're going to use something simple based on triangle stuff. So if you thought trig would never come back and haunt you, I have bad news. So say we have a right triangle, and we have some angle here, some angle theta. This is basically our wand, right? So our wand's right here. It has the little fiery stuff, and we know that we need to have it at a particular angle. So if this was the snowman here, and my mouse was right here, then we need to have it at some angle. Now, where this starting angle is, where we sort of consider zero angle, that is going to matter, and we're going to see how that matters here in just a moment. But in order to compute the angle, whatever this angle happens to be, I have my hypotenuse, right, on my right triangle. I have my x, and I have my y. Well, I've already computed the direction. I already have this vector. So I already know the hypotenuse. So there's a few ways that we can do this. Typically, I use a tangent. So from your sort of, if you guys learned like SOHCAHTOA or something, that was what I learned way back when I was doing trig stuff. The tangent is equal to the so SOHCAHTOA opposite, which would be y. A tangent of theta is equal to y over x. So in order to get the angle out of this, I do the inverse tangent on both sides, and I get theta is the inverse tangent of y over x, or it's the arctangent of y over x. It's the same thing. Inverse tangent, arctangent are the same. That's the equation that we're going to use to figure out what this angle is. Now, in Unity and in most languages, this is all done in radians. So this angle would be in radians. Well, we want to make sure that that's in degrees for us to do the actual rotation. So that's something that we'll mess with here in a second. There's functions for this in C#, so we're not going to really have a problem computing this value. But this is where it comes from. And again, we already have the actual vector, this hypotenuse that we actually need. So we already have the x and the y. And it's just easiest to use those. So we can clear the drawings off here. So I can create a float called angle. And I can say this is mathf dot, this would be a tan 2. It's not always clear that this is the arctangent and not the arctangent squared. That's an easy thing to get confused with. This is a tan 2 is just the arctangent with 2 arguments. So we need y and x. So I can just take my direction dot y and my direction dot x. And that's it. That gives me the angle, but remember, this is in radians. So I need to multiply this by a conversion, which we have easy access to, called rad 2 degree. So radians 2 degrees. So we get the angle based on our direction. We do the arctangent of that, y over x, and multiply by the conversion from radians 2 degrees. Then we have the angle. Now we need to actually rotate our wand by the appropriate amount. This deals with a quaternion, because eventually we're going to do this. We're going to say this dot transform dot rotation equals rotation. Rotation we're going to make here in a second. So let me actually do that. Say quaternion rotation like this. We're going to fill this in a sec, and this would be rotation. So this is the point. This is what we are doing. So that's why we're doing all this sort of math stuff to begin with. We need to compute the direction. We need to compute that what that angle corresponds to, and then we need to compute the correct quaternion to be able to do this last line right here. So for a quaternion, there's a nice function that a nice sort of static function that quaternions have called angle axis. Creates a rotation which rotates angle degrees. That's what we want, because I want to rotate by angle degrees. So we want this angle axis function. There's 2 arguments here. There's the angle. Well, we computed that. And then there's the axis. About what axis do we want to rotate through? Like what? So, it's the same thing as grabbing, which do I want to rotate X, Y, Z when I actually do my rotation. We can create, or we can use one of the static vectors. We can use a vector 3 dot forward. Now, I want you to think about what forward means. When we're just sitting here in Unity, and I'm going to go back to scene mode. When I'm just sitting here in Unity, and my gizmos are not be up here. They are, but I don't see my. See, back to 3D here. Here we go. So I was just in the 2D mode. But when you're sitting here in Unity like this, and you're in 3D mode. Y is up and down. X is to the left and right. Z is going to be forward and backward. So that's why I put in forward, because I want to rotate around Z. Because if we go back to 2D mode, and I grab my weapon, and I rotate along the Z. Oh, that was the position. I want to rotate along the Z. It rotates like this. So it rotates about that axis. You can think of the axis as going, coming out of your monitor or into your monitor. That's the axis you want to rotate around. So that's what that last argument is in the angle axis. So we want to rotate around that. Now, if you look at the slides, you'll notice that there is something that I have not put in here, because we're going to see what this looks like just doing it this way. There's one change that we're going to have to make to it. And then we'll be pretty close to done. Let's go in here. Not too bad. It's not pointing at my mouse, but it is rotating. If I point straight up, so I'm right above where this where my wand is, it's 90 degrees off. It's pointing over there. I rotate to the right, now it's pointing straight up. So I'm off by what looks like 90 degrees, and that is correct. And the only reason this is happening is because I've made some assumptions about where I say zero angle is. And Unity's assumption about where zero angle is 90 degrees different from my assumption. So what we need to do is we need to take our wand and we need to rotate it back, or start it back 90 degrees different from where sort of my angle, my assumption of my angle when we did that calculation with a tangent. So if I come back to the code, I'm going to take just right here, I'm going to say angle minus 90f. So I'm just going to subtract 90 degrees off of the angle that I calculated. And of course, you could do it in here, you could do it in here as well. It doesn't really matter. So I make that one quick change. And now the wand's pointed at my mouse. So these are a bunch of those little sort of vector things, sort of trig things, sort of algebra things that you might have to work with when you're trying to get sort of stuff to follow your mouse, or things to sort of point at other things, objects to move towards other objects, to compute these directions and angles that things need to rotate. Because, right, if I'm gonna shoot a bullet, for instance, if I had a projectile here that it mattered the rotation that it was when it came out of the wand here, then I'm going to need to make sure that projectile is rotated the correct direction. So even shooting projectiles, you might have to deal with a quaternion and an arctangent and all of that kind of stuff. So hopefully this at least sort of gives a little bit of understanding to what you need to do to have your mouse sort of interact, at least in some way, with the game, and what you might need to do rotation-wise to get things to rotate properly. And it can be frustrating. It can be very frustrating. When I did some custom physics for a pendulum type game, I made all sorts of assumptions about where the zero starting point was, and I had different frames of reference with different zero starting points for the rotations, and it was a pain, because Unity assumes potentially different things than we do. So this is in the slides. So if I go back over here, so it is in the slides, so it is all here, and I have little pop-ups that come in and sort of mention what each one of these things do. So the direction vector, the two-argument arctangent function, so tangent of theta is y over x, and creating the quaternion, the quaternion. I also have a get mouse button down here, so it's just get mouse button down 0, so that would be left click, and it actually plays the weapon particle, weapon projectile particle system. So that's something that I do want to add in as well. So this is still an update. So I'm going to say if input dot get mouse button down 0. It's my left click. I'm going to say weapon projectile dot play. We need to add that particle system. It's public, so we need to drag a particle system into this, and then it will play every time I click. Now, because I already have that set up, it should work right away once you grab the particle system and put it in there. But I still want to talk about the particle system a little bit because there's a couple things that are worth saying. So let that compile. Underneath the weapon here, I do have the particle system. So in my weapon object where I have the weapon script, I'm going to click and drag that particle system in. And wherever you're pointing, it should do something like this. So every time I click, it points out. And let's move over here. It should, we could always check, pull this down here. I want to check in the scene view to make sure that, or to check if it's hitting the collision there, and it's not. So it just continues to go, and it's going to go until the actual time on the particle system actually runs out. So we are going to mess around with some of that stuff. We're going to need to make sure that it disappears appropriately. Like when it hits an enemy, it shouldn't just go through the enemy. It should stop when it hits the enemy. So that's stuff that we're going to have to mess around with in the future. But I want to talk about what this particle system is actually doing, and sort of how it's doing this sort of one particle in the correct direction, and then I'll mention just briefly what we have to do to hook this up to our enemy stuff later, so the enemies can actually be sort of hit by the particle and take damage, because that's not something you normally think of a particle system doing. So the particle system itself, and I know this that this is a little small. I have a little bit more blown up version on the slides here. The main thing here is the emission is just a burst with one particle. So there's no rate over time, there's no rate over distance. It's a burst with a count of 1 and a cycle of 1. So that's it. It's just one particle, done. So it's a burst. The shape is a very narrow cone. So if I show you in Unity, and we go to the particle system and we look at the shape, it's just a very narrow cone. So it starts right here. And yes, it's a cone and it shoots out. And I don't know why the cone's so long. You could probably mess with that and get that to be smaller or sort of down. But it doesn't really matter. It's always going to spawn down here at the bottom of the cone, and it's going to shoot up. So it's a very narrow cone, so it doesn't have any sort of spread to it. If you wanted spread to it, if you didn't want it to be exactly straight out of a weapon or a wand like we have, then you could have the cone be a little bit more sort of open, so that you get this sort of randomness to it. And that's easy to do. In code, you'd have to go in and make sure that you could sort of spawn with a range of angles or something out of the actual spawn location. Here, you just change the angle that you're allowed to spawn from. So if I do something like this and I run the game, I should get something that's spawning in a variety of directions. So a very easy change to make with the particle system. So for now, you put the angle back down to 0 and it'll always shoot straight out. Otherwise, the rest of this is just, rotated into the correct position and all that kind of stuff. So there's nothing sort of major going on there, or nothing sort of major going on in the shape, other than just we've really simplified this cone down to have a very small radius and no angle at all. One of the things that's easy to miss is related to the simulation space. It's set to, I have it set to world. If I set this to local, it looks okay, but notice when I rotate, the particles are rotating too. This would be like the I don't know, like the tractor beam in Binding of Isaac, for instance. They're getting pushed so that they rotate along with my mouse. So the simulation space being local means that those particles are inheriting the local position and rotation of the object that spawned them. That's what local means. So if you don't want that to happen, you do have to set the simulation space to world, so that they don't interact with the thing that spawned them at all. So that's why I can shoot stuff off here and it doesn't follow the rotation of the actual object. So that's something that is sort of easy to miss and be like, what in the world's going on? So that's related to the spawning. So very simple slides here. Very simple emission. One particle, one cycle. Very simple cone. The graphic can be whatever you want. For this graphic, for the renderer down here, I just grabbed the default particle. Of course, you can put whatever particle, whatever material you want to in there. It's perfectly fine. There's nothing else that's changed here. The big one is collision. Big one's collision down here. So the type of collision is world, so they can collide with anything in the world. The mode is 2D, so it's going to respect 2D colliders. So it's going to be able to hit our enemies that'll have 2D colliders on them. There's a bunch of things like dampen and bounce, so you can actually have these particles bounce off walls or other stuff. What we want to do, you can have bounce on, you can do whatever you want to, but the biggest one that's going to make it so it disappears when it like hits an enemy and doesn't just bounce off the enemy if you don't want it to, is this lifetime loss. If we hit a collider, a 2D collider in this world, the lifetime loss is how much, like a percentage, of the lifetime of the particle gets taken away when it has a collision. I have it at 1. So all the remaining lifetime of the particle is gone. So all that remaining lifetime disappears. And so the particle's dead. The particle disappears. So that's a very important one, this lifetime loss. If you want it to bounce around, that's reasonable. Maybe you don't want it to have any lifetime loss. So it just bounces around. It doesn't lose any lifetime when it has a collision. Then you can turn that to 0. You can also have some speed here. So if the particle stops, so the minimum kill speed, if the particle stops, it disappears. The particle goes too fast, it disappears. So there's ways to do that with some of these too. The collision, you can change stuff related to the collision. So what does it collide with? Is there any sort of forces applied? This is how you can push stuff around. So you can push stuff around with your particles, and you can do things like send collision messages. That's what we need to kill our enemies. And then visualize bounds is just a thing to visualize where the actual collider is. So if we head back over here, and I'm going to pull the game mode out over here again, and depending on how choppy this stuff is, you should be able to see. Let's see. Let me click off of that. Actually, let me go here. You might barely be able to see, depending on how choppy stuff is, the bounds, the green sort of circle that's around here. So if I come up here we go. So there's my bounds of my projectile. Well, that's based on the collision that is set up here. So that's sort of what is sort of able to hit. It might be a little bit too big, in which case you have to mess with the actual graphic itself, because that's what it's based on. There's nothing in here that lets you mess around with the size of the collider other than the graphic itself that you're using. So that's how I get this sort of collision stuff going, and we're going to use that when we deal with the enemy. So later on, check the slides here. So later on, we're going to have this function. This is not in any code we've written so far. This is with the enemy. So this is in the enemy game object. It's going to be public void on particle collision. So when a particle collides with a function that has this method in it, and the particle system has send collision messages, this function will run. So the enemy will take damage when a particle collides with them that sends collision messages. So that's how we're going to do it. We don't need this code yet. We're going to add it in when we add in enemies, but for now, that's sort of how the rest of this works. So you can take a look at that. Take a look at the particle system. Take a look in the collision stuff. Mess around with some of those values. See what happens when you play around with them. See if there's anything sort of interesting that you can make happen. But when we create our enemies, we will make sure that they die when they take a hit. So yeah, so mess around with the weapon rotation, mess around with firing. I just did mouse button down. If you just do mouse button, then it'll just continuously fire. So if you want like a really rapid fire thing, or you want it to make sure it's every click or something, you can certainly do that. It's simply just playing that one burst, that one particle burst from the particle system. And that's basically it for today. So we're just about out of time. So or we are out of time. So we'll do some more Spectre coding. We're going to do enemy stuff next time. So we're going to have a spawn manager, an enemy factory, enemies, and maybe projectile. I don't know exactly how I split it up, but we will look at factory pattern, spawn manager, and at least getting some enemies spawning out there in our game world. So that is all. So I will see you guys on Thursday.
Thanks, Professor. I just had a quick question. Um, I'm not sure why, but for the public state class,